Longitudinal waves, which are sometimes also called compressional waves, are waves in which the particles travel in the same or opposite direction as the wave's propagation, so the wave's travel. Some examples of longitudinal waves are sound waves, which use the vibration of air or water in order for the sound to travel. Particle movement in an elastic medium, so things like an elastic band or a spring, because of the compressional component and then the elastic part of that material, they can produce longitudinal waves or act in the same way. And seismic P waves, which we see created by earthquakes or large explosions in the earth. So the way in which those waves move through the solid component of the earth are through seismic P waves, which are longitudinal waves. So this link here is going to help us to look at what a compressional or longitudinal wave looks like or how it behaves. A compressional or longitudinal wave is one in which the medium moves in the same direction or opposite direction to the wave's travel. So here, this slinky is behaving like our wave, and if we compress some of it and let it go, then the wave's travel is going to be that way, okay? But I want you to watch the ribbon that I've tied on here, and I want you to see what the direction of the ribbon does and see how it's behaving in relation to the wave's travel. All right, ready, go. So you can see that the ribbon is moving either in the same direction or opposite direction as the movement or the direction of the travel of the wave. So this is how the particles in a compressional wave work. It moves with or against in the opposite direction. This is different to your transverse wave. So remember, the transverse wave, the particles move at right angles. So in a transverse wave, if we're looking at a transverse wave like this, the particles are moving up and down, even though the direction of the wave is moving that way. I'd like to show you how to label the features of a longitudinal wave. There are some features that are the same between a transverse and a longitudinal wave, and there's some unique features just for longitudinal waves as well. So let's have a look at this top diagram. There's a few different ways that longitudinal waves can be represented in diagrams. We'll start with this one first because this one looks like the slinky that we were demonstrating with before. If we look at how the slinky or how this particular diagram is represented, you can see here that the particles are really close together. As you move further along to the right, here they are more spread apart, and then they come back together again over here. And so when they are compressed like this, we call those sections compression. So we've got the same thing here and here. They're both compressions. And in the middle, where they're more spaced apart, we call that rarefaction. Now, from one compression to the next compression, or from one point on the longitudinal wave to the same point on the next longitudinal wave, we call that the wavelength. So the definition is the same between the transverse and the longitudinal wave. It just looks different on the diagram. And remembering that in a longitudinal wave, the displacement of the particles are going in the same or opposite direction to the wave's travel. So this is the displacement. In this case, the displacement of the air particles or whatever the medium is that the wave is being transferred through. So let's have a look at another diagram. So this one at the bottom of the page there, it does look a little bit different to the top one, but again, we can still see those main features. So this time we're representing our longitudinal wave with lines, And here we can see that there is the compression section where the lines are really close together. So I'm going to label that as the compression. Here where the lines are really spaced apart, we call that rarefaction, the same as in the above diagram. And again, the wavelength is from one compression to the next compression. And this arrow here is showing us the displacement or the movement of the particles in relation to the direction of the travel. And one last diagram, the other way we can see it represented is with dots. So again, if we compare it with the other two diagrams, we can still see that these sections where there are a lot of dots all close together, and that is where we still call that the compression. So this part here, compression, and where they're further apart, like we can see here and here and here, that is called the rarefaction. And just like all the others, if we go from one compression to the next, that's our wavelength. So each of these three types of diagrams show us our longitudinal wave just in different ways.